when we talk about the second part of our lecture, what we call it blood transport of gases. So we mention or we mean the transport of oxygen and CO2 and the carriage it to blood. So when we talk about the oxygen transport first, oxygen transport means that each 100 milli arterial blood can carry a 19.5 milli oxygen, يعني around 20 milli oxygen. Oxygen, how it can be transported? It could be transported into two forms, either physical form or chemical combination. The physical dissolved, it is only small amount. It is around 0.3 milli CO2, 0.3, only 0.3. It is only physical dissolved, not combined to anything in plasma. And this could reflect the BO2 in our blood. يبقى when I mention the BO2 in blood, I mention the amount physically dissolved, and it will reflect the amount of oxygen loaded upon the blood on blood and the direction of the oxygen. يعني when something contains than the other, so this PO2 or oxygen will transport from an area that have PO2 more than the other, or PO2 higher than the other compartment. Also, we will have oxygen in chemical combination, either in combined with not either, sorry, the oxygen chemical combination, we mean the oxygen binding to hemoglobin, and it contains around 98% of oxygen. يبقى around the 98% of oxygen present in chemical combination with the hemoglobin and affected بالأنيميا طبعا, of course. But a small amount, maximally 2% أو around 0.3 milli oxygen per 100 milli per 100 milli, this will be physically dissolved. When we talk about the chemical combination, so we talk about the amount combining with the hemoglobin, and only each one hemoglobin contain 4 molecules of oxygen. This reaction is rapid and reversible. يعني here we can load it with oxygen, and here we can release the oxygen in the same manner. How it can do this? By the method of oxygenation. So carriage of oxygen occurs through oxygenation, not oxidation. The ferrous in hemoglobin remain ferrous, not become ferric, and each hemoglobin molecule contain 4 globin before ferrous, before for oxygen, and it can carry it in cascade manner, and each step can accelerate the next step to occur. So when part of the hemoglobin or subunit carry oxygen and become 25% saturated, it accelerates the second subunit to be saturated, and also the third subunit, and so till full saturation. This is what we call it oxygenation in cascade manner. What we mean about the oxygen content, it can come to you as definition. Define the oxygen content, define the oxygen capacity, define the oxygen release or utilization. So in oxygen content, we mean the amount of oxygen present in 100 milli arterial blood in chemical combination with hemoglobin. And when we mean only the amount that chemically combined with hemoglobin, so we mean the content. This is the content. And also it depends on the hemoglobin content and also the oxygen tension, the physical dissolved amount. What about the oxygen capacity of the blood? The oxygen capacity of the blood, it is the amount of oxygen present in 100 milli blood in chemical combination with hemoglobin when it is fully saturated. Again, what we mean about it, the oxygen capacity, the amount of oxygen in 100 milli blood in chemical combination with hemoglobin when it is fully saturated. يعني ال content means the amount present in 100 ml blood in chemical combination with hemoglobin. This is the content. When this content become, when the hemoglobin fully saturated, so we mean it the capacity, the maximum amount could be carried in chemical combination, and this depend on the hemoglobin content. Hemoglobin content 15 gram percent ده average. So when we calculate the 15 gram percent multiplied in the amount carried by each gram hemoglobin can carry 1.33 milli oxygen. So 15 multiplied in 1.36 it equal around 20 milli oxygen. So this 20 milli oxygen can we call it the oxygen capacity. يبقى again, what is the difference between the capacity and content? Both are a carriage of oxygen بالhemoglobin in chemical combination in 100 milli arterial blood, but the capacity when it is fully saturated. This pulse oximeter will can measure LbO2, can measure the saturation also. That utilize the tissue over the 20 milli come to tissue. يبقى 20 milli اللي جوه التيشو only we utilize ال 5 milli اللي هم 25%, 1/4 of the amount of blood coming to the tissue. And this amount could be increased up to 75% during exercise or hypoxia when the oxygen tension at tissues become less than 40. When the tension less than 40 as during the exercise, so there will be rapid unloading with oxygen or rapid excretion of oxygen at tissue from the blood, so saturation will be decreased rapidly in vertical step manner. يبقى again we have an oxygen dissociation curve 3 parts. One plateau, then curved, then vertical or step. This will occur at lung, this at the tissue during the rest, this at the tissue during exercise or hypoxia. First at lung, we speak about alveolar oxygen tension. Alveolar oxygen tension when decreased from 100 to 60 due to any disease or high altitude, so saturation of the pulmonary capillaries will decrease slowly, reaching 90%. But when the oxygen tension at tissue decreased to 40 millimeter mercury, so the saturation become 70%, يعني decrease saturation 30% to give more oxygen للtissues during the rest. And less than 40 during the exercise, it will release the oxygen rapidly to give extra needs of oxygen للmetabolic activity. I hope you understand this oxygen dissociation. This oxygen dissociation curve could be shifted to the right or shifted to the left. Shifted to the right means this when we are at 20 millimeter mercury BO2, normally saturation will be about 35. During a shift to right, with 20 millimeter mercury tension, saturation become 25, يعني less saturation. يعني it means that we give oxygen more rapidly. يبقى here shift to right, give oxygen more rapidly, more unloading with oxygen. Give oxygen more للtissues even under high pressure, or release oxygen more tissue. This can occur during hypoxia, less oxygen, less CO2, or less more CO2, more hydrogen, more temperature. These occur during the exercise. During the exercise, there will be hypoxia, there will be less oxygen, more CO2, more hydrogen, more temperature. This could occur in exercise, so this could accelerate or shift to right, shift the curve to right to give more oxygen to tissues. Also, what we call it the 2,3-diphosphoglycerate that can come in RBCs during anaerobic glycolysis with high metabolic activity of RBCs. This also occur in exercise, occur for high metabolic activity, so means we need more oxygen. The contrary is shift to left. Shift to left means we can preserve, blood can preserve oxygen for a long time and not release it to tissues, and this occur in the opposite case when we have more oxygen, less CO2, less hydrogen, less temperature, and also in what we call it fetal blood or fetal hemoglobin. If you remember, in fetal hemoglobin contain alpha 2 gamma 2, and the gamma combine with the oxygen strictly and not let it to be released. Also CO poisoning, we will discuss it in hypoxia, and this CO bind the hemoglobin and prevent the hemoglobin to release the oxygen. Also stored blood that can destroy 2 and 3-diphosphoglycerate. يبقى again oxygen transport physical 0.3, chemical combination 98%. The chemical combination carried on hemoglobin in cascade manner for oxygen molecule in oxygenation. We have oxygen dissociation curve. The oxygen dissociation curve could be shifted to right, will cause shift to right, or could be shifted to left, will cause shift to left. What about the CO2 transport? Our blood or our arterial blood, 100 milli arterial blood contain around 48 milli. 48 milli CO2 can be increased up to 52 or 53 milli in venous blood. So this amount of blood in arterial blood could be carried also physical, around 5% of the amount physically dissolved in plasma. Also in chemical combination, we will have in two forms, either carbamino binding to the protein or in form of bicarbonate. El carbamino around 6% of the remaining amount, and around 89% could be carried as bicarbonate. When we talk about the bicarbonate will be formed in plasma and in RBCs, مش formed, will be present in plasma and RBCs. Plasma in form of sodium bicarbonate, RBCs potassium bicarbonate. In plasma more than in RBCs, يبقى sodium bicarbonate more than potassium, about 3:1. This sodium bicarbonate in plasma, we can call it alkali reserve, and it is present in our blood to counteract or antagonize or neutralize the acid released from the body metabolism. When I asked you about the alkali reserve, this is the amount of bicarbonate present in plasma of 100 milli blood. Right? The correct. Some amount physically dissolved, and the remaining will go to the RBCs, either binding with the hemoglobin protein in carbamino or combining with the hydrogen water في the presence of carbonic anhydrase enzyme to become carbonic acid, and this carbonic acid is very weak to be dissociated into hydrogen and the bicarbonate. The hydrogen buffered with the hemoglobin, buffered with hemoglobin when it carried بالhemoglobin, so it accelerate unloading للأكسجين, يعني الهيموجلوبين will release الأكسجين to carry this hydrogen. The bicarbonate when formed mainly about 75% of the bicarbonate formed will go to the plasma to combine with the sodium to become sodium bicarbonate, and this will be in exchange with the chloride. This passage of the negative ions will create positivity inside, so chloride will be attracted and the water will be shifted with the chloride. So this what we call it chloride shift. What will occur in chloride shift? In chloride shift, the bicarbonate will increase in RBCs and also in plasma. The bicarbonate will pass in plasma, so in exchange with the chloride, and the water pass with it, so the volume of RBCs will be increased about the volume of the RBCs will be increased about 3% greater. يعني ده الفوليوم called الهيماتوكريت اللي هي الفوليوم of RBCs in 100 milli blood will increase 3% in venous blood more than the arterial blood. The reversal of chloride shift, it is the reverse.